Now today we discuss about plane. So concept of plane you studied in class 10. You just know when we extend all the sides, then that surface is nothing but the plane. But here we require the definition of plane in the form of a line, or we have to find the equation of plane in terms of vector. So we define plane as a plane is a surface such that if 2 points lie on it, then entire line joining them lies on it. That means here we consider this surface. When we consider 2 points on this plane and we join these 2 points, that is, we draw a line passing through these 2 points, then this line also lie in this surface. That means as this line extend, this surface also extend. So we denote this arrow, that means this surface extend as this line extend. So what is difference between quadrilateral and this plane? In quadrilateral, these sides are fixed, length of these sides is fixed, but in plane we can extend all these sides in all possible ways. So this is a plane, and you can define plane in this way. A plane is a surface such that if 2 points lie on it, then the entire line joining them lies on it. Now we see the equation of plane in terms of vector. Now we see vector equation of line passing through a point and parallel to a vector. Here, instead of parallel vector, we require a perpendicular vector. So first we find vector equation of plane passing through a point and perpendicular to a vector. So we see theorem based on it. So first topic is equation of a plane passing through a given point and perpendicular to a given vector. So see the statement of theorem 8. The vector equation of a line, the vector equation of a plane passing through the point A of A bar and perpendicular to a non-zero vector n bar is r bar dot n bar is equals to a bar dot n bar. So we see proof of this theorem 8. So first we draw a figure for proof of this theorem 8. So we write here proof. So first we consider a plane passing through the point A of A bar and perpendicular to a non-zero vector n bar. So we consider here this plane which pass through the point A of A bar with position vector A bar, and this vector n bar is perpendicular to this plane. So we first write in proof, let A bar, or we write here let A of A bar be a point lie on a plane, or you can write a plane passing through a point A of A bar and plane perpendicular to vector n bar. We consider here a point P, any point P other than A. So we write position vector of this point A with respect to O as A bar, position vector of point P with respect to O as R bar. So we write here, let P be any point on plane with position vector R bar with respect to origin O. Now these 2 points lie on this plane, given plane. That means this AP also lie on that plane. So this vector n bar is perpendicular to this AP. So we write here, since n bar is perpendicular to plane, that is n bar is perpendicular to AP. So first we find the vector AP. We write vector AP. Therefore vector AP is equal to vector AO plus vector OP. We have the value of vector OA. So we write this as minus vector OA plus vector OP. Position vector of OA we represent by A bar. So we write minus A bar. Position vector of OP we consider as R bar. So we write vector AP is equals to minus A bar plus R bar, or we can write R bar minus A bar. So denote this as equation number 1. Now we write here n bar is perpendicular to the plane. That means this n bar is perpendicular to the vector AP. So we write here, therefore, or you can write reason, since n bar perpendicular to AP bar, therefore n bar dot AP bar is equal to 0. So we write here n bar, or you can write this also, AP bar dot n bar is equal to 0, because dot product is commutative. So we write this form. So AP bar we write R bar minus A bar. This n bar as it is equal to 0. So we multiply by dot product. So we write R bar dot n bar minus A bar dot n bar is equal to 0. So from this we write R bar dot n bar is equal to A bar dot n bar. So this is vector equation of plane passing through a point A of A bar and perpendicular to the vector n bar. So in this way we can find the vector equation of a plane passing through a point and perpendicular to the given vector. परत एकदा तुम्हाला हा थिअरम समजून देतोय मी. आपल्याला अशा प्लेनचं इक्वेशन फाइंड करायचं आहे की जो प्लेन या पॉइंट मधून पास होतो ए ऑफ ए बार मधून आणि या वेक्टर n बारला परपेंडिक्युलर आहे. म्हणून आधी आपण काय केलं, एक प्लेन कन्सिडर केला जो या पॉइंट ए मधून पास होतो, ज्याचा पोझिशन वेक्टर ए बार आहे आणि या वेक्टर n बारला परपेंडिक्युलर आहे. त्यानंतर आपण याच प्लेनवर अदर दॅन एक पॉइंट घेतला पी, ज्याचा पोझिशन वेक्टर आपण आर बार कन्सिडर केला विथ रिस्पेक्ट टू ओ. आता ही लाईन फॉर्म झाली या ठिकाणी एपी, किंवा हा वेक्टर आपण कन्सिडर करू वेक्टर एपी हा त्या प्लेनवर आहे. म्हणजे जर हा n बार वेक्टर या प्लेनला परपेंडिक्युलर असेल तर त्या प्लेनवरच्या प्रत्येक लाईनला किंवा प्रत्येक वेक्टरला सुद्धा काय राहणार, परपेंडिक्युलर राहणार. तोच कन्सेप्ट आपण इथे यूज केला. जर ते दोन वेक्टर एकमेकाला परपेंडिक्युलर असतील तर त्या दोघांचा डॉट प्रोडक्ट 0 असतो. म्हणून आधी आपण त्या वेक्टर एपी ची व्हॅल्यू फाइंड आउट करून घेतली. वेक्टर एपी ची व्हॅल्यू फाइंड करायसाठी आपण ट्रायंगल लॉ यूज केला. ए टू पी पाहिजे होतं, तो आपण ए टू ओ आलो, नंतर ओ टू पी आलो. आपण ती व्हॅल्यू या फॉर्म मध्ये लिहिली बाय ट्रायंगल लॉ ऑफ वेक्टर एडिशन. एपी इक्वल्स टू वेक्टर एओ प्लस ओपी. आपल्याला वेक्टर ओए माहिती आहे म्हणून आपण त्याचं डायरेक्शन चेंज केलं. म्हणजेच निगेटिव्ह वेक्टर घेतला, मायनस ओए केला. वेक्टर ओए ची व्हॅल्यू आपण रिप्लेस केली ए बार हे मायनस साइन ॲज इट इज. त्याला लिहिताना फक्त फर्स्ट टर्म सेकंड टर्मच्या जागी लिहिली, सेकंड टर्म फर्स्ट टर्मच्या जागी लिहिली. त्यानंतर आता आपण कन्सेप्ट यूज करून राहिलो की n बार परपेंडिक्युलर टू एपी, म्हणजेच त्याचा डॉट प्रोडक्ट 0. वेक्टर एपी आता हा डॉट प्रोडक्ट कम्युटेटिव्ह आहे. तुम्ही एपी आधी लिहिला काय, n बार नंतर लिहिला काही फरक पडणार नाही. मग एपी बार डॉट n बार इक्वल्स टू 0. वेक्टर एपी ची व्हॅल्यू काढली आपण आर बार मायनस ए बार फ्रॉम इक्वेशन 1, ती रिप्लेस केली. इथे स्केलर मल्टिप्लिकेशन आहे, डॉट प्रोडक्ट इज डिस्ट्रीब्युटिव्ह, तो डिस्ट्रीब्यूट केला. आर बार डॉट n बार मायनस ए बार डॉट n बार हा फक्त राईट हँड साईडला शिफ्ट केला आणि या फॉर्मला म्हटलं आपण वेक्टर इक्वेशन ऑफ प्लेन पासिंग थ्रू Now see next theorem, theorem 9. The equation of plane passing through the point A of x1, y1, z1. That means here coordinate of point is given and direction ratio of whose normal are A, B, C. So instead of vector n bar, here normal of this plane whose direction ratios are given. So from that we can find the vector n bar. From the coordinate of point A we can find the position vector of point A, and P is any point. So we use here concept. If this vector n bar is perpendicular to this plane, means this vector n bar is perpendicular to this vector AP. So first we write the position vector of point A. We write here A bar be the position vector of point A. Therefore A bar is equal to x1i plus y1j plus z1k. If we consider P of xyz be any point on the plane, so we write here let r bar be the position vector of point P, or you can write point P of x, y, z, point P of x1, y1, z1. So we write here r bar is equal to xi plus yj plus zk. So we find here vector AP. So vector AP is equal to position vector of P minus position vector of A, that is r bar minus A bar. So we calculate the value of r bar minus A bar as x minus x1 into I, y minus y1 plus y minus y1j plus z minus z1. Now this vector n is perpendicular to vector AP, so their dot product is 0. Here direction ratios of normal is given. Therefore normal vector n bar is equal to, we write ai plus bj plus ck. Now these two vectors are perpendicular, so their dot product is 0. So we write here r bar minus a bar dot n bar is equal to 0. So from this we write r bar minus a bar means this vector. So we write here x minus x1 I plus y minus y1 j plus z minus z1 k dot ai plus bj plus ck is equal to 0. So we multiply I with I. So we get x minus x1 into a, I dot I is 1. So we write here, we require a first. So we write a into x minus x1 plus similarly for j dot j1. So we write here b into y minus y1 plus c into z minus z1 is equal to 0. So this is Cartesian form for the equation of plane passing through the point A of x1, y1, z1 and direction ratio of normal are ABC.